Hi guys. Well, this is dynamic callbacks for persistence. I'm going to show you something I started researching or creating time ago, pulling different things from different techniques that people was using or APTs they were using. The purpose of this is not for explaining how to do this. It's more as a baseline that can be used for implementing on any ways that you want any code. It's called not stick, so you can do this with anything. I have a few demos that I'm going to be showing with PowerShell, but it's just because it's easy to show with PowerShell, but you can do it with anything. Okay, let's start. I'm Strange, security consultant, researcher, a few projects, Fruity Wi-Fi, Fruity C2, Fruity DNS, Fruity Proxy, and one that is coming related with this research. The problem, for the red team perspective, the blue teams are getting better on detecting C2 infrastructure, so they are detecting that quickly. Maintaining persistence for a long period of time is getting harder. Distributing and managing multiple callbacks can be a challenge. And keeping targets connected to the C2 infrastructure can have a short period of time. Thinking about that, today they were talking about different red team scenarios, and they were talking about different levels of maturity in the companies. I am talking here a company that has a high maturity and is not falling into a silly macro that is not being detected when PowerShell is picking up from there. So we are talking about a SOC or a company that has a good maturity in terms of detecting this. Dynamic callbacks, this is my proposal for this, can be used for establishing communication with the C2 infrastructure and for achieving persistence. Red team and the bad guys, they can take advantage of these techniques, of course. The concepts that I'm going to explain are code agnostic, so you can implement this with Python, with PowerShell, with C#, with whatever. It's about the concept and the technique that I'm going to explain, and not about how to do it. Okay, phone home. You're going to notice when I start talking about this, you're going to say, well, but yeah, we know that. Yes. But what I did was to give an extra step forward into how to use something that is already being used, but how we can use it for getting a better persistence or better communication with the C2 infrastructure. So, simple scenario, we have a target, we have a C2 outside, we have the proxy. This is going to be everything over internet, so we are going to have the corporate proxy in the middle. Okay, we send a phishing campaign, we send tons of emails. Someone received the email, open that, wherever that is, could be a link, could be a macro, could be anything that that company is allowing to receive and to be executed. And that is connecting with our C2. Okay, we have connectivity, but after a few minutes, after an hour, depends how fast is the detection on that. If that is detected and our phishing contains the same callback, sending to the same command and control, well, the rest of the files that you already delivered, they're not going to work. If it is work already at the proxy, forget it. Whatever work that you did, whatever hundreds of emails that you sent, if you are sending the same IP or the same domain for going back into the C2, it's not going to work anymore. Similar scenario, you have multiple IPs or multiple domains, and you are distributing that maybe between different emails. You are sending multiple emails, but with different IPs, or the same email with the same payload that has 4 or 5 or 10 IPs or domains that is going to point. Okay, the first is connected. They're going to do, the SOC knows that is happening, so they found that, they block that. And maybe the other ones that you have already in your payload, they're going to start connecting to other ones. Okay, but if there's someone is doing the reverse into the payload, they're going to find all your callbacks, if we call it callbacks, or the IPs where you are connecting, or the domains that you are connecting, and they're going to start blocking all of them. So also you're going to have a short life of where it's going to be connecting with the C2. I'm going to remove the proxy there, just for having a little bit more space on screen, but it's going to always be there. When I am talking that is doing the communication out, it's going to be always through the proxy. Dynamic callbacks. This is a story where the story begins. Okay, same situation. We have a target. We have our C2. We have something somewhere outside on internet. So the proxy is there, but they're going to remove that from there. The proxy is there. So the idea is to do a request to that thing. We are going to get content, and from that content we can do different things. Depends on the level or the layers that we want to put there. We can parse the code, decrypt, if we also added some kind of encryption to that content that we are getting. So it's up to us how we want to implement that. And then when we get what we need, we can patch our payload, and the payload is going to connect to our C2. You're going to say, well, yeah, we already saw that on forums or Twitter or getting content from another place. Yes, it's something that having used for some time for a few APT groups. But we have something else that we can do for not being static, for not going always to the same place. I'm going to put a few redirectors in the middle. I'm going to have always that because I don't like to connect directly to my C2. I always put redirector for everything. But in this case, okay, I'm going to have redirectors there. It's my recommendation. Don't expose your C2 directly. Okay, so when that happens, getting the content, patching, extracting the IP or the domain, and then patching your payload, is going to connect to one of the redirectors. The redirector is going to connect to the C2. If you see from the beginning, that is going to happen a couple of times. Every time that the persistence, we are talking here that we already get access into the machine, so we can deploy the persistence if we want, and every time that the persistence is going to run, it's going to do something different. It's going to do the request, it's going to get something, it's going to connect to other redirector, and every single time that the persistent trigger is going to be something new that is getting from outside. And that's the trick. What to do with that, how to get that information and how to change that information. Also, the good thing about this is if you're requesting content, you can change your IPs or your domains because you have control of that if it is outside. So the point of this is you don't need to hardcore any IP or any domain into your payload. Dynamically, you're going to get something from outside, and that is what is going to give you the content where the payload needs to connect. That's the idea. So, but what's that thing that is blinking there? Well, that thing could be anything that you have control. If you have something that you have control, and it's not just a single page, I'm putting there, you can put whatever that you want, but I'm putting there things that they are commonly not blocked, or they are things that you can abuse in some way and it's not going to be blocked. So, for example, you have YouTube, you have Google as Google search. Well, AWS, you can start doing domain fronting, you can do domain fronting also with Google. So you have different places where you can put content that you can change on the fly any time that you want, and every time that the persistent trigger is going to get the new content that you are changing. So, the story again. Request something to any of these places, get the content, extract the IP or the domain where it's going to connect, patch in the payload that you have, or also you can get dynamically the payload and get in the payload already with the IP. But okay, in this case, imagine that you already have the payload, you're just changing where it's going to connect. Alright, so an example. Request the data, what you are requesting. In this case, I am using a hash that is a SHA-1, but you can use anything. Anything that is unique enough to be found. So if you are doing a search on Google and you are searching for a string, well, a string that is unique enough for finding that and not being lost in a lot of content that you are getting. Okay, so what you get in the return is this. It's a long string. In my implementation, you can implement this in different ways, of course. That is why I was saying that it's more about this as a baseline, and how you implement that is up to you. So in this case, I have two different hashes, and I have a domain, that is a fake domain in this case, in the middle. So the first part, you have a hash, then you have something in the middle, that is the IP or the domain where you're going to connect, and then you have another hash. Why I have that? Well, let me show you. So there I extract the domain that is in the middle, and I have the extra hash. The first part, the part in the middle, that is the domain, is what I'm going to use for patching my payload. So I patch the payload, I connect, cool, but then I do something else. Because initially what I used, it was the hash, the first hash, So what I am doing with this is searching for that somewhere, matching with the first part that I have in the hash, and then I know what I'm going to have after. So what I am doing is ignoring that part. I am not going to use that hash anymore. And once someone asked me, but that hash means that this type B. No, that hash is just a hash. I create a hash running a command. I create a hash, and that's it. It's free creating a hash. So I create tons of hashes, and I was distributing hashes everywhere. So that hash, I am not going to use that hash anymore. And the next time that the persistent run is going to use the other hash. So the next time that my persistent run is going to be a new hash. So if you imagine this, every time that you are searching for something and you are getting the content, you are going to get always a new hash. And you can multiply that on different ways. If you say that you have multiple places where you're going to be hiding this, and you have multiple hashes matching other hashes, that the hash is giving you another hash, well, you can see how this is difficult to follow. If someone says, well, I found the first hash, let's search. Yeah, but you're searching there. I have the hash there. So you're going to be getting different hashes every time. So how you get all is going to be difficult. So that is the core thing. Where you can find, or when you can hide this, website, any website. So the idea is you extract the data, you parse, you decode or decrypt, depends on the layer that you put there, and you get the callback. You can put that on Google Sites, on YouTube, on Google Maps, on Google Drive, and I am not poking Google. People are telling me, you're using just Google for this. No, Google is giving me all these places for free. I don't need to pay for anything. I am just putting the data there, and that's it. Then I do the search onto those sites, but you can use any site that you know that is allowed by the company that you are testing or doing the engagement or whatever you call it. Searches, you can search on Google. So you search on Google and Google is going to give you the result. I'm going to show you examples with all of this. GitHub, you can search things on GitHub and GitHub result is going to give you what you want. Domain fronting, Google, Amazon, Microsoft, anything that is allowing you to do domain fronting, you can combine this. It's not just doing domain fronting for getting this. It's doing domain fronting for going somewhere and then combining that with a different domain that is allowed. I'm going to show you examples with that. DNS, you can have that in the TXT record, for example. Open your mind. You can put this anywhere. These are just examples. But you can put there on any service or any site that you think, okay, I have control of that. I can change that whenever I want, and that's enough. Okay, an example, the first one, let's see, is GitHub. Okay, so if I do a search on GitHub, I'm going to get a result, and I'm going to extract the data, and let's see how it looks like. So GitHub, without any credentials, it's just normal user, not authenticated with the site. I'm going to search for my hash. That could be any string, of course. Search for that. And in issues, in the case, could be in other places, it could be in the wikis, I have the content that I want. So I get this, I extract, remember that I mentioned the different parts. The first part is the hash that I am searching. The second part, divided by pipes, is my domain where I'm going to connect, and then I have the new hash that I'm going to use the next time. Another example, with Google is interesting. Well, all of this for me is interesting, but okay. I search for a hash in Google, and Google is what is giving me the result. Because Google is going to be crawling pages, and in the result that Google is giving you, I'm going to have the content that I want. So, the same, I extract the data, connect this to, let's see the example. So, if you search on Google for hashes, this is what happens. It's giving you nothing. And this is something that changed not long time ago, a few years, because I started with this a few years ago, and the first time that I was searching for hashes, it was giving me the result. But now it's not giving me a result anymore, but just changing something, let's say that it's not a hash, it's something else. So if I put an underscore, it's giving me something. So you can see that the result is now there. So in the description of the site, I have the content that I want. This one, of course, is not that easy to change. You need 5 hours. It's not terrible. But, okay, it's not that it's immediate. It's not that you change the site and then Google is going to update that in the description. No, it's going to take a few hours at least. But depends what service you are using, because also you can use Google stuff for searching on Google stuff. So if I search another hash, there, let me zoom in this a little bit so you can see from the back. That is sitesgoogle.com. And inside google.com, if you put content, you don't need to do much for Google to start searching into this. You just enable in the site, tell Google to scroll my page. And that's it. And it takes, when I was playing with this, I noticed that takes less time for Google to search into sitesgoogle.com than to update what I have in one of my domains. So using Google Sites, combining with Google Search is a bit faster, and who is blocking Google, right? So if you put this for getting your dynamic callback, that is where your payload is going to connect, just using Google is more than enough for implementing this functionality, if you want to call it like that. Okay, let's see another example. YouTube. You can put your content on YouTube comments or in YouTube videos descriptions or in different places, but you can use the comments. That is cool. But in this case, I'm going to use it for something else, for showing you something else. I can do domain fronting with any Google, not any, almost any, Google domain against any Google domain. If I want to go to Google, but I am saying that in the host header, I am not going to explain domain fronting, but it's very simple. You do a request to a place, and you say in the host header that you're going to a different place, and if the infrastructure that you're hitting is allowing you to do that, you are going to go to the site that you put in the host header and know in the request. So, in this case, I am using YouTube to go to Google Sites, because in my company, Google Sites is blocked. So, okay, I can't go to Google Sites, but if I front with google.com or with youtube.com or with anything Google owns and is allowed, Google Maps, for example, I can go to the site that I want to get the content. So you can, this is why I say that you can start combining things. So I'm sorry, you get the dynamic callback and you patch the thing. An example with domain fronting very quickly. I go into sitesgoogle.com. What I am showing here that is not allowed. I have the DNS are pointing to my machine. That is why it's not going out, but it's simulating that it's blocked. Okay, so that doesn't work, but let's start messing with this. So if I go into youtube.com to the same path that is my sitesgoogle.com, okay, it's not finding anything, so I am repping there for searching for my domain, but it's not finding anything, okay. But if I add the host header saying that I want to go to sitesgoogle.com, same as before, but I just added the host header, now I get the content. So that is what I am doing with domain fronting with Google, for example. I want to go to sitesgoogle.com, but I am using youtube.com as the first page that I'm going to hit. How it looks like, a hint for the blue team, and what you can do for to detect domain fronting very quickly. Okay, let's put that there. You have the target is connected to a proxy, to a site that is allow-domain.evil, /evil, so that is where I want to go. But in the host header, I have forbidden.domain. That is a domain that if I try to go directly, it's not going to be allowed in that proxy because the domain is blocked. It's not allowed. But this combination is allowing me, after hitting the domain fronting black magic, that is not black magic, simple, then it's hitting forbidden.domain.evil, that is getting the content, right? So what you can do for detecting this? Well, if you have the visibility, this is important, and you check that the host header is different to the request, well, you can find potential domain fronting being used for evil. Why am I saying that? Because domain fronting as a thing is not evil per se, it's just something that you can use. But okay, you need to start doing analysis as analyst SOC side, and if you say, okay, well, this is not normal, you can detect how if it is being used for evil. But of course, I mentioned about the visibility. If you are not getting the headers, if you are not getting the host header of that request, forget it. You're not going to know that that is happening. If you know that and you detect that it's evil domain fronting, you can block it. Another example, DNS. Some people always, when I mention this, is telling me, oh, but in my company I can't resolve external domains. Okay, I am not saying to resolve the domains internally. What I am saying is, well, you can use a broker. You can ask a page that is allowed for getting the detail from the DNS. So let me show you how this looks like. I'm going to do it in the command line, and then I'm going to show you with the broker. So in this case, I am doing dc.fruityx.co.uk. That is what I get in the txt record as a SPF record normal. But if I change to dc.1, dc1.dc and the rest, there is my content in my txt record. And that is what I'm going to show you with the broker. I have this page that usually this page is open and never find any problems on accessing this page. So if I do the same, searching for that, first I'm going to get, of course, the normal record, but if I search for the other domain, subdomain, I get what I want. And of course, I can extract the content from the page, and I can get the callback from there, plus the hash that I'm going to use the next time. FruityDC. As part of this, I thought, it would be cool to have a tool for instead of going to the site and put the data there, to have a tool that just pressing a button is doing psh, and sending all the hashes to everywhere, GitHub, Google, and all the places that I have APIs, of course, for pushing the data. So that is what I did. So the tool is called Find Redirected User Internet through your dynamic callbacks. So these are a few screenshots. I'm going to release this soon. Yeah, I know that I haven't been saying that for 8 months, but I'm going to release it soon. So this is how it looked like. I have different hashes. Here it's telling me if it's in sync with the site, because I am setting everything on the application, and then I can press a button saying push, and then it's going to send that to all the sites. Another screens, you have a simulator also. You can start checking if the logic of how the hashes are flowing are hitting the correct C2s that you have. This is a simulation site. Not necessarily. You need to have the C2s responding to your payloads. It's just a request. It's telling you if it's set correctly. And then you have a console that you can run a few commands from there, also send a few emails. I'm going to show you something with that. Also, you can check just clicking on the links where it's taking you. I'm going to show you a few examples. So this is Google. I have the hash there in Google. This is Google Sites. This is Google Drive. Google Drive is cool. Hey, let me tell you about this one because I think it's interesting. If I pause this. Okay. Google Drive. People is telling me, yeah, but if you change the file in Google Drive, when you change the file, the link that you have for that file is not going to be the same link anymore. So if you access that, you're not going to get the new content. If you change just the description of the file, yes. You can change the description of the file and the link is going to be the same. So you can keep using the same link, but just changing the description. That is what I am using here. I'm using the description of the file. You can continue using the same link that you create with a file a year ago, and just you can keep updating the description on the file. So you can keep modifying the data, that's the point. Google Maps, you can create a map or you can put content somewhere and you can put the data there. Who's blocking Google Maps? I don't think so. And then any site that you can use. This site is cool, WriteUs. It's a site that is not, you don't need to create a user. You just go to the site and you create content and you get a unique link and you can use that unique link and you can change the content and the link is the same. You don't need to distribute a new link because the link is the same. So the path that you have is not going to change, but you can change the content. This is how it looks like, the setup in FruityDC, a little bit. So you have a key, could be a string. I am using hashes, but you can use whatever you want. I have the DC, the dynamic callback, where it's going to connect. I have the new hash, that is what is going to be replaced, then not replaced, but yeah, in the machine that is the target, it's the new hash that is going to be used on the next search. Then where is going to be for the testing purpose of FruityDC, but you can have the same hash from multiple places, of course. And you have an extra field, because in some cases you're going to have a URL that instead of doing a search, you just add an extra value. In this case, like the ID. If you're using Google Maps, you can create a map that the map is going to have an ID, and that is the URL plus ID that you should distribute. So this is a configuration of FruityDC just for showing you the idea. Okay, so here's how I'm going to start showing you things, how can be implemented, how this can be implemented. I have here 5 hashes. So we're going to imagine that you have your payload, your macro, your exe, your whatever that you have, that you are going to distribute. I put in 5 initial hashes because it's going to be just the first 5 hashes in the file. After that, all of this is going to start being dynamic. You need to start somewhere. So 5 initial hashes, and as part of the payload, I also put different methods. I call the methods the URLs where the hash is going to be checked. Could be a Google search, could be the Google sites extracting from there. So the method is where you're going for checking for the hashes. That's the idea. So I'm going to show you a flow, a representation on how this payload will be working, replacing the old hashes and getting the new hashes. So random, 1 hash, random hits all the sites as soon as match 1 connects. So that hash is not going to be anymore. It's used for the next hash. It's searching for a different place. It's finding the other server, and you understand the idea, right? Every single time that you do a request, that the persistent trigger, I am proposing this as a persistence method and not a constant communication. If you start using this as constant communication, well, now someone is going to notice that something odd is happening. The idea of this is use this for the persistence. As soon as this triggers, keep that channel slow and quiet and start moving around for getting away from that persistence. Keep that running, for example, twice a day. So you would know that you're going to keep communication in case that all the other channels that they are noisier are being shut down by the SOC, for example. That's the idea. Okay, so I'm going to show you something running now, and I am using FruityDC as part of the simulator piece, just for counting the hits that the payload, this is a real thing running, in this case it's going to be Python, how it looks like in the background. So the hash is the same, 5 hashes, and now randomly it starts searching for the hashes and getting a method, checking all the methods, so you're going to see that it's hitting different URLs until it finds one that is matching with the hash. So that is what it's doing, and that is why I'm saying that if you start putting a lot of methods and a lot of hashes in your initial payload, well, this gets crazy. You don't know where it's going. Could be, if you have the hash, the same hash distributed in different places, depends where it goes the first time, it's going to get a different hash. If you are using a different hash for the second hash on each of the methods, if that makes sense. So it's cool, right? So that's the idea. Let's try it. Let's see if the live demo works. Because also I want to show you, in a video was a little bit difficult, so we're going to try to do it live. I'm going to also show you how I'm thinking that also the hash can be reused on the target. So we're going to have a machine, let me go there. I'm going to have a machine that is the target, and I'm going to have a combination of FruityDC and FruityC2. FruityC2 is a C2 tool that I created it's not for using for enterprise, to be honest. It's for researching. So it's simple. You can modify that in any way that you want. So it's good for research and for understanding how these tools works. That is the purpose of FruityC2. So we're going to use FruityC2 as the C2 server, and FruityDC for showing you a couple of things. Okay, I have this machine. Imagine that I sent already an email, someone click on the thing, and now some kind of malware is running there. So now I'm going to run the commands manually, of course, because I want to show you step by step what I am doing and how I am combining this with FruityDC. First, let me see if I have connectivity. Yeah, that's okay. Let's try another one. Yep. Yep. Okay. Right. So I'm going to start messing with registry keys because I'm going to show you how the persistence can work there. You can use this in different ways. You can have a config file, but you're going to be touching disk. So it's up to you how you want to implement the persistence. In this case, I'm going to use registry keys that they are not common register keys. The only thing that I want to do is to put the data somewhere, and that's it. I don't care, well, yes, you care how you're going to trigger the persistence, but in this case, I'm going to show you how the persistence is getting the data for start doing this dynamic thing of the callbacks. So, let me show you. I have a PowerShell script here, so I load the script that is the malware in this case. So I have a few variables. Let's see. The DC key, let me zoom in this a bit so you can see it better. Let's put it there. Okay, so I have a key. The initial key is you can have multiples. I'm going to do it simple for not doing a mess. So I have a SHA-1 file, a SHA-1 hash there. And also I have a method. I'm going to use just one method, but you can put multiple. It's going to be GitHub. So I'm going to do the searches on GitHub. So those are my things. And now I'm going to show you how this looks like without patching the payload, and then I'm going to patch the payload. So I have a function that is getDC that I need to pass two things. I need to pass the method. So the method is going to be, well, what I have in that variable, that is DC method, and then I need to pass the key, that is the initial key that is going to do the search. Or the key that is getting from registry keys for different places for continuing this automatically without me doing it manually, of course. DC key, so if I run this, it's doing the request, and this is what I get. I get, well, the request is this one, and you can see that I added the hash as part of the search for the method that is GitHub, and this is what I get. I get the same hash that I'm searching because it's what I am using for matching that I get the content that I want. You can implement this differently, of course. I have the DC, well, direction, yeah, the domain, and I have a new hash. So here, the three things. Okay, cool. So what can I do with this? You need to have automatically to put this somewhere, right? Because the next time that the persistent is going to run, you want to get the next hash, that is the one that's starting in 47, right? So that is the one that we're going to use the next time. So what I am doing for that? For that, I am using a registry key. Let me first initiate that. I'm going to initiate the registry key. I call it SteelCon, so you can call it whatever. I am putting that in the environment variables for the current user. So there we have the hash. Okay. So I'm going to run now the payload manually, not manually. I'm going to run the payload in the way that the macro or the exe or whatever is going to execute this. So I have a function that is runMe. That runMe, what it's doing is getting the hash from the registry key that I am defining somewhere, and then doing the search. And then it's going to update the registry key with a new value. So remember that we are starting with the 27, the hash, I mean, here. So that one. Let's run this. So if I run that, so you can see here what is happening. The initial search for the value that needs to use for the method is a 27. Okay, it's doing the request, it's getting the content, and now the registry key contains the second hash. That makes sense? Let me show you what I have now in the registry key. So if I check the value in the registry key, you can see that, yes, now it's the 47. Before it was the 27, because I am using the next hash that I get from that request. Let's run it again and see what we get. Now it's going to search for the 47 hash, and let's see what we get. Now we get a 0C. So that is what I have now in the registry key. So makes sense? I am doing a request, I am getting content, I am using the part in the middle as the domain or IP that I'm going to use to patch my payload and then connect with my C2. And also the second hash is what I store somewhere for use the next time that the persistence run. So let's now patch the payload and see if that is connecting with RootC2 that I have here on top, but also you can see it here on the side. So I'm going to run the same function that is runMe, but I'm going to add patch true. It's just how I implement the function, not much in there. I'm just saying, yeah, patch the payload and connect. That's it. Okay, so patch the payload. Now it's executing through the C2 stager, and you can see here, now, you have a machine on top. So here, if I do ls, for example, I get content, because now I connected to that machine with that request. Let's keep that machine there, but let's run it again, see if we get another one. But this time, see that we have the before, so that is what needs to search next time. Let's run again. Boom, we have another machine. If I run it again, we have the 7A, searching for 7A. Now it's updating 27. Boom, we have another machine. So that's the idea, right? The idea is you get content, you patch your payload dynamically for the persistence, and that is connecting with whatever domain or IP that you are defining on the content that you have outside that you are getting dynamically for doing this. I hope this makes sense. Okay, let me kill these machines, stations, so we can keep this clean. So we're going to show you the next demo. But before to show you the next demo, let me explain what I'm going to do. Let's go back to the presentation. Right. Time, we're okay. Right, so you got email. Just thinking how you can implement this, I thought, okay, well, instead of having something that is always running, well, yeah, instead of something that is executed and doing the search, I'm going to decide when the payload is going to run. Instead of having the persistence triggering on a specific time, I'm going to send the information for the machine to know that needs to do the dynamic callback flow for patching the payload and then connecting back. Let's see how this is going to look like. But first I'm going to do a representation. So I have two servers, two redirectors pointing to the EC2. I have an SMTP because I'm going to send an email. I send the email. I already have compromised that machine, right? So I have already something on this machine. I already sent an email, already is there waiting for my command to do the stuff. So I send an email, and because I send the email, the machine says, okay, cool, yeah, I know what I need to do. Matching the persistence, trigger dynamic callback, it's getting good content, in this case from YouTube, but could be any place. Patching and connecting. Let me show you the demo. Let's see if the demo works in the same way that the other one. That was cool. Okay, I have Outlook here. I'm going to keep this shell open there because I'm going to run the thing that is running in the background manually. That's the point of the shell. That's it. And also to show you the flow of the communication. And I'm going to use FruityDC. Let's see which one of these we can send. So let me increase font here a little bit. Okay, so we're going to send the key, the 47. That is the method 2 or 2. Okay, so we're going to send this, the 47. Remember that number. So if I go to the console, let's put that there so I can show you. First, before doing that, almost forget about this. First, I'm going to run something because I'm going to set what I want to set for that persistent to run. So I have a function that is called Outlook rule create. So this is going to do two things. Let me increase a little bit more of this. This is going to do two things. It's going to create a rule in Outlook, and also it's going to create a new folder in Outlook. So here under delete, you're going to see that a new folder is going to pop up. Creating the folder, there is a folder. And there is the rule. Let me show you the rule. I don't need any privilege for this. It's the same context of the current user. So the rule is saying, let me increase this, when the subject contains any of these happy faces, this happy face and this cat happy face, it's going to move the email into move. Right? So let's send the email. Let me increase this here so you can see what I am sending. Also, I'm going to put, let me close this. I'm going to put in the display of on Outlook, the move folder so you can see when the email arrives. I think there is going to be fine. So let's send, I think we say 2. Yes, the 47, so it's 2. Send 2. Okay, so it sent the method GitHub2, starting with the 47 key. This is the subject, how the subject looks like with the happy face at the beginning, then the hash. The victim is this email, that is X victim, outlook.com, you can see on the other side that the email arrived, right? So there you have the email. So now let's run the thing that is going to execute the value that is there. So I already have something checking all the time on this folder. But let's put FruityC2 here so you can see if I am connecting into that. Okay, so let's put it there. Now you're going to have on this side if the machine is being connected with the C2, and you're going to see that this email is going to disappear. Well, that's it. Let's see. So the function that I have is Outlook DC client. So we're going to run that. Email being processed, removed from there, matches, check a few methods, different methods. Let's see if it hits one that matches. Cool, yeah. So it's hitting the GitHub, dispatching the payload, and now we have a machine. There, it's connecting with the C2 with the information that was extracted from here. So it's the SteelCon C2, that is the domain that is connecting, right? So just for fun, let's run the config. See if I get something, but it's not the point. Yeah, okay. So I'm connected to the machine. Cool, right? So I showed you different ways that you can trigger this persistence. I think the method, I'm going to show you something else with Outlook because I think it's fine and we have time, so it's okay. So you can do something else for using that method without being that obvious, because now you have a folder that is called move. And someone maybe is going to notice that they have a folder that is called move, and before it was not there. So let's see what we can do with that. Let's keep that shell running. I can kill it so you can see the difference when connects the new one. Kill jobs. Alright, so it's going to die. Okay, so I have another function before to send a new email, because we need to trigger the persistence, that is called Outlook hide folder. Remember the folder there, move. Let me zoom in this a little bit. Right. Move there. I'm going to say folder hide true by folder. The folder is not there anymore. But still there, I just hide in the folder. So if I send a new email, let's go back to FruityDC. So now let's send, I don't know, B4. Okay, console, send 4. So we're sending the cache before with the happy face at the beginning before, so that is what is going to be processed by my malware running there. But you don't see the folder is not there. But still there, and that is what I want to show you. So let's put FruityC2 again here. So that machine is dead. You can see that it's not running anymore. I can't run any more things there. So we are going to wait for a new one. So let's run again the Outlook DC client and see what happens. Zoom in this a little bit. Because the important part now is, well, also you need to see FruityC2, right? So let's leave it there. Run that. Searching, finding the matching happy face plus hash, checking the methods, it's finding GitHub, it's connecting, and now we have another machine. So let's do less. And that's it. So what I did was to use the same of the folder, but this time I have a folder hidden. So it's going to be less difficult to notice that they are using this for persistence, for receiving the data. Instead of putting that in registry keys, as I did before, instead of doing that, I just send emails with the data. The only thing that they can do for noticing this is if they check the rules, and they are going to find a rule that they didn't create, but that's it. Apart from that, the folder is not there. It's not visible. Okay, so that's the demo. Let's go back to the presentation. Okay. This is the same demo as the Outlook, so I'm not going to show you the video. It was just in case that it didn't work. Lateral movement and persistence. Okay, this is more about recommendations and how to use this. It's not for showing you a demo. But we can mix a little bit how how we can use this as lateral movement and persistence and being quiet and how to move into a more noisy channel. So, okay, let's say that we have a machine that we compromise, that is this machine. We have that, we compromise or we move laterally, right? Because not necessarily needs to be the first machine that you are compromising. Maybe you are compromising the network, you are being super noisy, they are going to know that you are there. Maybe you have 20 minutes, you already have credentials, so you can start moving around. So if you are quiet enough for moving around, a hop, another hop, another hop, you can put the persistent, leave it there. Let's say, okay, tomorrow is going to run. Every Monday, yeah, could be every Monday. Could be every day, could be every Monday, could be any time. At a certain time, the persistent method is going to run. It's going to have the dynamic callbacks. That's the point of this. It's going to search for information on the internet. It's going to get the new domain or IP, and it's going to connect to that persistent C2. But that persistent C2, let's keep it slow, super slow, so that communication could be low, low, or just one hit, until you do what you want. Maybe the only thing that you want to do is to be sure that you have a machine that is connecting out, and as soon as connected, as you know that you have the persistence, you can kill that channel. Kill the channel, so the machine is not going to be doing requests to your C2, and just wait for the persistent to trigger again, in case that you are losing communication on other channels. So what are the other channels? Well, from that persistence channel that is slow, 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 you can start moving around, you can get into the network and jump into other machines, and from a place that you are far away from that initial machine that you have for persistence, you can start triggering other channels to other redirectors, to other C2s, keeping that C2 persistent very low in terms of noise with the dynamic callbacks. So keep this channel like this, just for persistence, and then do your noise in other places. So you can trigger multiple machines against multiple redirectors. So you do all the mess there, you do all the noise there. If you lose channels, you can spin up new channels. You can do that from the persistent channel, or you can do that from the other channels that you have. Do the noise there, keep the persistence on a side. Don't use that much unless that you need it. So that is the purpose of my proposal for this, is using this for persistence and not for constant communication. You can use it for constant communication, but my idea for this is for persistence. And also you can open other channels to the same. You can have multiple machines doing this persistent method very slowly on different times, using different methods. Maybe you are using on this machine one method for persistent scheduled task. In this one you're using services. On another one you're using the Outlook thing. So you can distribute that in different ways. And you can do that with different methods. The one that you're using with scheduled task, maybe you're going to use Google stuff. And the one that you're using with Outlook is going to use AWS domain fronting, for example. So you can mix this in any way that you want. Okay, so I have a few recommendations. They are general recommendations. It's not mainly about this. It's how you can detect this. Detecting the dynamic callbacks, I would say that is difficult. Because if you are saying that you are using only Google searches for distributing your data, it's going to be very difficult to find at the proxy level, right? So if you know that something is running in a machine because you have something like, well, any DR that is cool and is finding that something is running weirdly, not normally, well, maybe it's going to detect the execution, but not what you are doing in terms of communication, because doing a search on Google, that is not going to be strange at all. So that's the idea of the recommendations. For the red team, prepare your infrastructure and tactics in advance. For example, don't buy the domains the week before or the day before that you're going to use it, because they are going to notice that you have a domain that is very young, or certificate that is very young. Segregate infrastructure and team members based on functions and roles. So it's cool to distribute that between different infrastructure and people being in charge of something. Maybe someone is going to could be in charge of the persistence, just being sure that the persistence is running. Use a redirector between targets and your backend for anything, for DNS, for web servers, for the SMTPs, for anything. Don't expose directly your infrastructure. Keep infrastructure and persistent and noisy infrastructure away from each other. Don't use the same server. Doesn't make any sense. If you're using persistent one server or domain and you're using the same for the noisy infrastructure, well, you're not doing it right. Don't reuse exposed infrastructure for persistence. So if you know that they cut your persistence, burn everything and start from scratch, because they can use the fingerprint of that machine for finding the new servers. If you have an image, then you are using that image for creating the same server, well, it's going to look the same. They're going to be able to find that. If they are using Showdown and they're searching for that, they're going to see that it's the same. Use domains that are relevant to your operation and check the healthiness. Don't use a domain that is highlighted as malware. If that is your purpose, it's fine, but if you want to use that thing, it's not going to work. Do not use code or default parameters that can be exposed to your operation. For example, the malleable profile-ish things that all the different C2s have their own implementation. They are cool, but don't use the default, because the default probably they are being monitored. Change methods of persistence between targets. That is what I was saying about use the services with one method, with a few methods. Use the schedule tasks with other methods. And don't use your dynamic callbacks method and change the patterns between the payloads. So, for example, don't use the same happy faces that I am using. Change that, and you can implement different ways the dynamic callback thing for different machines. So instead of using the pipes in the middle, so you can have more hashes. Maybe it's not just one hash at the end. Maybe there are multiple hashes at the end. So that could be more difficult or more dynamic in the way that it's taking different routes. A few recommendations for the blue team. Don't allow internet or LAN access without establishing a VPN to the corporate network. So in that way, you can see what is happening in the proxy. If you're allowing the machines to connect to internet in the home networks, well, maybe the malware is checking that it's not in the corporate network and it's not going to do anything when it's there, and it's going to wait to be outside of the network. Every single external communication from the corporate endpoint should pass through the corporate proxy. The same. Compare the web request with the host header, so in that way you can find domain fronting. You need to inspect the SSL traffic, because if not, you are not going to see the host header. Increase log visibility on whatever that you have connected into the network. You need to do review of those logs. If you are collecting logs and you are not doing anything with that, why you are collecting logs? Implement next-gen machine learning, super-duper endpoints and network protection. It's not an AB. Perform hardcore red team and blue team exercises. This is good for knowing how strong is your security and your defense, and also it's cool for training the people that is in charge of that. So doing constant, let the red team to get in and do things, don't stop them. Well, stop them if you are finding them, but that's the point. Cyber threat modeling teams and intel teams, they are cool for increasing the knowledge of the defense and how to increase the security. And the threat hunting teams also, they are cool for finding these kind of weird things that they are not the normal type of malwares that you can be getting. So that's it. Thanks.